Have you ever wondered how one teenager changed mathematics, invented one of the world's first mechanical calculators, made groundbreaking discoveries in physics, and still found time to become one of history's greatest philosophers? This is the incredible story of Blaise Pascal, a brilliant mind whose ideas continue to shape the modern world centuries after his death. From solving impossible mathematical problems at a young age to creating inventions far ahead of their time, Pascal's life was filled with extraordinary achievements, relentless curiosity, and deep personal struggles. Most people know his name because of Pascal's Triangle or the Pascal programming language, but very few know the fascinating journey behind the man himself. His discoveries influenced mathematics, probability, engineering, computer science, physics, and even philosophy. Without Blaise Pascal, many of the technologies and scientific principles we rely on today might have taken much longer to develop. In this documentary, we'll uncover the untold story of the boy genius who challenged the greatest minds of his era, built one of the first mechanical calculators to help his father, unlock the secrets of pressure and probability, and left behind ideas that still inspire scientists and thinkers around the globe. Stay with us until the end, because Blaise Pascal's remarkable life proves that one brilliant mind can truly change the course of history. Blaise Pascal was born on June 19, 1623 in Clermont-Ferrand, France, into a family that valued education and intellectual curiosity. His father, Etienne Pascal, was a respected mathematician and government official who believed that his son possessed extraordinary potential. After the death of Blaise's mother, the family moved to Paris, where his father took complete responsibility for his children's education. Rather than following traditional methods, Etienne designed a unique learning program that encouraged curiosity and critical thinking. He initially kept mathematics away from young Blaise, believing he should first master languages and philosophy. But Pascal's curiosity was unstoppable. At just 12 years old, he independently discovered basic principles of geometry, astonishing his father with his natural talent. Recognizing his son's exceptional abilities, Etienne introduced him to some of the greatest scholars in France. Pascal soon attended meetings with leading mathematicians, where he impressed experienced scientists despite being only a teenager. At the age of 16, he wrote an extraordinary work on projective geometry known as the Essay on Conic Sections. The publication amazed Europe's mathematical community. Many scholars could hardly believe such advanced ideas had come from someone so young. This early achievement established Pascal as one of the brightest young minds of his generation. As his father's work required endless tax calculations, Pascal watched him spend countless hours performing repetitive arithmetic by hand. Wanting to ease this burden, he set out to build a machine that could perform calculations automatically. After years of experimentation and refinement, he created the Pascaline, one of the world's first successful mechanical calculators. Constructed with gears and rotating wheels, it could add and subtract numbers with remarkable accuracy. Although expensive to manufacture and not widely adopted during his lifetime, the Pascaline became a milestone in the history of computing. It demonstrated that machines could assist humans in solving complex numerical problems, laying an early foundation for the development of modern computers. Pascal's interests extended far beyond mathematics. He became deeply fascinated by physics, particularly the behavior of liquids and gases. During the 17th century, many scientists believed that nature could not tolerate a vacuum. Pascal questioned this widely accepted belief. Through carefully designed experiments, he showed that atmospheric pressure changes with altitude. He asked his brother-in-law to carry a mercury barometer up a mountain while taking measurements at different heights. As the altitude increased, the mercury level dropped, proving that air has weight and pressure decreases with elevation. These experiments transformed scientific understanding and became fundamental to fluid mechanics and atmospheric science. Today, the SI unit of pressure is called the Pascal in his honor, a lasting reminder of his groundbreaking contributions. Engineers, meteorologists, physicists, and countless others use this unit every day. Often without realizing it commemorates a brilliant thinker from the 17th century. Another area where Pascal changed history was probability. Together with fellow mathematician Pierre de Fermat, he exchanged letters about gambling problems that puzzled wealthy nobles of the time. Their discussions led to the creation of probability theory. What began as an attempt to answer questions about games of chance eventually became one of the most important branches of mathematics. Today, probability plays a central role in finance, economics, medicine, insurance, artificial intelligence, weather forecasting, and scientific research. Every time experts estimate risk or predict outcomes using statistics, they are building on principles that Pascal helped establish. Despite his remarkable achievements, Pascal's life was not easy. He suffered from chronic illnesses that caused severe pain for much of his life. Frequent headaches, stomach problems, and weakness often confined him to bed. Yet even during periods of poor health, his mind remained active. Instead of allowing suffering to defeat him, he continued writing, experimenting, and searching for deeper truths about the world. In 1654, Pascal experienced a profound religious transformation after what he described as a powerful spiritual encounter. This event dramatically changed the direction of his life. He became closely associated with the Jansenist movement, a Catholic reform group that emphasized humility, faith, and moral discipline. While he never abandoned science or mathematics, he increasingly devoted his energy to philosophy and theology. During this period, Pascal wrote the famous Provincial Letters, a series of essays defending his religious beliefs while criticizing certain practices within the church. Written with wit, intelligence, and sharp logic, the letters became literary masterpieces, admired even by those who disagreed with his conclusions. Pascal also began writing what would become his most famous philosophical work, Pensées, meaning thoughts. Although unfinished at the time of his death, it remains one of history's greatest collections of philosophical reflections. In these writings, Pascal explored the meaning of life, the limits of human knowledge, happiness, suffering, reason, and faith. He argued that human beings possess extraordinary intelligence, but are also deeply flawed and limited. One of the best-known ideas from Pensées is Pascal's wager. He suggested that when considering whether God exists, believing in God could be viewed as the more rational choice because the potential reward is infinite, while the potential loss is limited. Whether people agree with the argument or not, Pascal's wager continues to inspire discussions in philosophy, theology, and ethics around the world. Pascal believed that reason alone could not answer every important question. He famously wrote, "The heart has its reasons which reason knows nothing of." This idea expressed his belief that human understanding involves both logic and personal experience. It remains one of the most quoted statements in philosophical literature. Even while focusing on philosophy, Pascal continued inventing. He helped develop ideas for public transportation in Paris by proposing one of the earliest organized bus systems. Although simple by modern standards, the project reflected his desire to improve society through practical innovation. Pascal's influence extended across countless fields. In mathematics, his triangle became a fundamental tool for algebra, combinatorics, and probability. Students around the world still learn Pascal's triangle because it reveals remarkable numerical patterns and relationships. In physics, Pascal's principle explains how pressure applied to a confined fluid is transmitted equally in all directions. This principle makes hydraulic systems possible, allowing machines such as car brakes, hydraulic lifts, heavy construction equipment, and aircraft controls to function efficiently. His work on pressure, fluids, and probability influenced generations of scientists, including Isaac Newton and many others who continued expanding humanity's understanding of nature. His inventions and theories became stepping stones for future discoveries that shaped the modern scientific world. Sadly, Blaise Pascal's life was remarkably short. Years of poor health gradually weakened him. On August 19, 1662, at only 39 years old, he died in Paris. Although his life ended far too soon, his legacy had only begun. Centuries later, Pascal's name continues to appear everywhere. Scientists measure pressure in pascals. Mathematicians studied Pascal's triangle. Computer scientists recognize his influence through the Pascal programming language, named in his honor. Philosophers continue debating his ideas about faith and reason, while historians celebrate him as one of the greatest intellectuals of the scientific revolution. What makes Blaise Pascal truly extraordinary is not simply the number of his achievements, but the remarkable range of them. Few individuals have made lasting contributions to mathematics, physics, engineering, philosophy, literature, and technology, all within a single lifetime. Even fewer accomplished so much before the age of 40. His story reminds us that curiosity has the power to change the world. A boy who once explored geometry on his own became one of history's greatest thinkers. An inventor trying to help his father created a machine that foreshadowed the computer age. A scientist questioning accepted beliefs transformed physics. A philosopher wrestling with life's deepest questions left ideas that still challenge humanity centuries later. Blaise Pascal's genius was not limited to solving equations or building machines. His greatest gift was his relentless desire to understand truth from every possible angle. Whether studying numbers, nature, or the human soul, he pursued knowledge with extraordinary passion. That relentless pursuit is why Blaise Pascal remains one of history's most inspiring figures. A genius who truly changed mathematics, science, and the world forever. As we reach the end of Blaise Pascal's remarkable journey, one thing becomes clear. True genius isn't measured by how long someone lives, but by the lasting impact they leave behind. In just 39 years, Pascal transformed mathematics, revolutionized science, pioneered mechanical computing, and challenged humanity to think more deeply about life, reason, and faith. His discoveries continue to influence the modern world, from the computers we use and the engineering that powers our cities to the mathematics behind artificial intelligence and scientific research. Few individuals in history have shaped so many fields with such extraordinary brilliance. If you enjoyed discovering the incredible life of Blaise Pascal, don't forget to like this video, subscribe to the channel, and turn on notifications so you never miss our next journey into history. Share this documentary with friends and family who love history, science, and inspiring stories. Thank you for watching. And remember, history is filled with extraordinary people whose ideas continue to shape our future. We'll see you in the next documentary.